The moon landing on July 20th, 1969, represented humanity's greatest technological achievement. Apollo 11 placed Neil Armstrong and Buzz Aldrin on the lunar surface, while Michael Collins orbited overhead. Approximately 600 million people watched on television, making it history's most watched live event. The mission symbolized American technological superiority during Cold War competition and demonstrated human capacity to accomplish seemingly impossible objectives. The space race originated in Cold War competition between Soviet Union and United States. The Soviet Union achieved early dominance launching Sputnik in 1957, shocking Americans. Yuri Gagarin became first human in space in 1961. American space program appeared inferior. President John F. Kennedy proposed moon landing goal in 1961, pledging Americans would land on moon before 1970. Kennedy's commitment transformed the space program, unifying efforts around specific lunar objective. Congress approved massive budget increases, enabling unprecedented NASA mobilization. The Soviet Union pursued moon landing equally aggressively, but faced internal conflicts. Soviet program split between competing design bureaus lacking unified direction. Chief designer Nikolai Korolev died unexpectedly in 1966, disrupting the program. Soviet moon program experienced technical problems and funding constraints, while American program benefited from unified NASA structure and unlimited funding. American program gradually surpassed Soviet efforts. NASA's Apollo program required unprecedented technological development. Wernher von Braun designed Saturn V rocket, history's most powerful rocket generating 7.5 million pounds of thrust. The Saturn V successfully launched all Apollo missions. The command and service module contained astronauts during launch and return. The lunar module was designed specifically for moon landing, featuring ascent and descent stages. These systems required innovations developed by 400,000 workers across America. Mercury and Gemini programs prepared astronauts for moon landing. Mercury program, 1961 to 1963, achieved first American space flights. Gemini program, 1965 to 1966, developed essential techniques including orbital maneuvering, spacewalking, and rendezvous procedures. These programs proved moon landing was feasible and survivable. Apollo 1 tragedy killed astronauts Gus Grissom, Ed White, and Roger Chaffee in 1967. Command module caught fire during launch rehearsal test. NASA implemented major redesigns, improving spacecraft safety. The tragedy delayed Apollo program 20 months, but resulting improvements prevented similar disasters. Apollo 8 orbited Moon in December 1968, confirming moon travel was feasible. Astronauts Frank Borman, Jim Lovell, and Bill Anders orbited Moon, transmitting television images to billions worldwide. Apollo 10 descended to 8,400 meters above lunar surface in May 1969, confirming lunar module performance. These missions provided final confidence that moon landing could proceed safely. Apollo 11 launched July 16, 1969, with Neil Armstrong, Buzz Aldrin, and Michael Collins. The three-day journey proceeded nearly flawlessly. Armstrong and Aldrin separated in lunar module Eagle on July 20th, while Collins remained in orbit. Armstrong manually piloted during final descent, avoiding Boulder Field. With fuel nearly depleted, Eagle landed successfully. Armstrong reported, "The Eagle has landed." Armstrong descended lunar module stairs and stepped onto moon surface at 2:56 Universal Time Coordinated July 21st. Armstrong reported, "That's one small step for man, one giant leap for mankind." Armstrong spent 2 hours 30 minutes exploring, collecting 21.5 kilograms of samples. Buzz Aldrin descended 19 minutes later, spending approximately 3 hours on moon surface. Aldrin and Armstrong deployed seismic sensors, retroreflectors, solar wind detectors, and conducted geological surveys. They planted American flag and left medals honoring deceased Soviet cosmonauts. The lunar module ascent stage successfully launched from moon surface. Armstrong and Aldrin ignited ascent engine, separating from descent stage. Ascent stage reached lunar orbit, achieving rendezvous with Columbia. Michael Collins performed manual rendezvous procedures. Successfully docked spacecraft allowed astronaut and sample transfer. Eagle's descent stage remains on Moon. Apollo 11 returned July 24, 1969, splashing down in Pacific Ocean with astronauts safe. After 21 days quarantine, astronauts underwent public celebrations. Scientists analyzed 21.5 kilograms of samples revealing moon rocks age approximately 3.8 billion years old. The samples contained igneous rocks formed through volcanic processes. Lunar samples demonstrated Moon possessed geological history and composition different from Earth. 6 Apollo missions landed successfully on Moon between 1969 and 1972. 12 astronauts total explored the Moon. Apollo 15 introduced Lunar Roving Vehicle, enabling extended exploration. Astronauts explored extended areas impossible with walking. Apollo 17 in December 1972 conducted most extensive Moon exploration. Apollo 13 explosion demonstrated Moon landing's risks. Oxygen tank explosion crippled spacecraft. 3 astronauts faced potential death in disabled spacecraft. Mission Control coordinated emergency procedures. Astronauts transferred to lunar module using it as lifeboat. They successfully returned to Earth through improvised repairs demonstrating human ingenuity overcoming life-threatening emergency. Moon landing transformed technological innovation. Spacecraft computer miniaturization advanced computing technology. Materials science innovations enabled spacecraft construction. Communications technology advanced through spaceflight requirements. Microchip technology accelerated through NASA demands. Medical technology benefited from astronaut monitoring systems. These technological spin-offs contributed substantially to broader society. Moon landing inspired worldwide public enthusiasm. Children pursued science and engineering careers. Universities experienced increased engineering enrollment. Moon landing demonstrated humans could accomplish ambitious objectives through determination. Nations worldwide developed space programs inspired by moon landing. The achievement represented humanity's greatest collaborative accomplishment. Space race competition declined after moon landing. The primary objective achieved established American space dominance. Soviet space program never achieved moon landing and shifted toward space stations. Cold War competition remained, but moon competition concluded. International cooperation eventually emphasized collaboration over competition. The Apollo-Soyuz test project in 1975 featured American and Soviet spacecraft docking, demonstrating reduced Cold War tensions. Moon landing's scientific legacy remains profound. Lunar samples continue generating insights about Moon's geology and history. Evidence indicates Moon formed from giant impact between early Earth and Mars-sized object. Moon landing enabled comprehensive understanding of lunar processes and composition. Lunar science continues expanding through orbiting satellites and robotic missions. The Moon remains target for future space missions. NASA's Artemis program aims returning humans to Moon. Commercial space companies pursue lunar activities. Moon landing influenced human consciousness profoundly. Astronauts reported overwhelming psychological impact viewing Earth from Moon. Astronauts described Earth's fragility and beauty, inspiring environmental awareness. The perspective influenced recognition of Earth's uniqueness and finite resources. Environmentalism gained impetus from astronauts' descriptions of Earth from space. Moon landing demonstrated humanity's capacity for extraordinary achievement. The accomplishment inspired confidence that other challenging problems could be overcome through determination and cooperation. Moon landing remains humanity's greatest expansion into cosmos, demonstrating civilization's potential for extraordinary achievement.